Hello, I'm Arthur. Welcome to my lab. A while ago, I demonstrated how I've added quad extrusion to my hypercube. And today let's take a look at how exactly I did this from the electronics and the software configuration standpoint. So this is my MKS Gen 1.4 board. It's all plugged in, so hopefully those of you with MKS Gen can recognize what's the orientation of this board and what is what. Those without MKS Gen, I guess this video won't necessarily apply to you, or if you take the idea and apply it to your own board, then you'll have to figure some of these things out on your own as to how to connect this extension to your board. But basically what I'm doing with my MKS Gen board is that it has this dual LCD connector on the edge of the board. And since I'm not using your regular LCD display, my LCD display plugs in right here. This is the smart LCD that has its own controller, so it's not using the controller from the 3D printer's board. I'm not using these two ports for your standard LCD port. So I've decided to use one of them for my extension board. And here's the extension board. It's mounted just right above my MKS Gen board. And for now, I've removed the drivers, stepper motor drivers, to show you how it's all mounted and how it's plugged in. Here's the power supply connection, just soldered straight onto the board. If you want to put a connector on the board, you can do that. Actually, when I designed this PCB, I used the wrong footprint, so the connectors that I have don't fit, so I had to solder my power connection. So there's a ribbon cable that goes from one of these ports, and it's kind of difficult to plug it in while looking at my phone, but here it is. So I'm plugging in this ribbon connector into this port closest to my stepper motor drivers, and the other end gets plugged into my extension board. That's all you need to do, just plug it in. And then of course plug in your stepper drivers and hook up your two extra motors. And my software definition is such that motor number 3 or extruder number 3 goes on top, extruder number 4 goes on the bottom. You can switch this around if you need to, and that's how you hook it up. And the drivers, in my case, I'm using DRV 82 whatever, the Texas Instrument DRV chips. I always forget their designation. They go in like this, with a trim pot going this way towards the capacitor. So that does the trick. And let's take a look at the extension board itself, and let's see what it does and how it does it. Here's what you need to build this extension board. This is the PCB itself. This is the board that you'll need, and it will add two motor drivers. You will need this IDC socket. This is 2x5 size, and I prefer to use the keyed style. You can use bare pins like this, but it's much better to use the keyed style so that you don't plug in your cable wrong way around. You will need some of the female headers, and you can buy them pre-cut to size. Just buy whatever number of pins you need, or I have some of these 40 pin strips, and I just cut them to size and use a file maybe or sandpaper to even out the edges after cutting, and that works fine as well. So this is a pre-cut, or this is a cut strip that I used. Of course I would cut it a little bit longer. I just grabbed one that I had floating around. This is not the one for this particular board, but you get the idea. Just, you know, size this header, cut it to size, and you're good to go. So that's what you need. 2-row headers for your jumpers for the setting the stepping of the motors, and again I just buy them in bulk in 40 pin lengths, and I cut them to size. So you'll need 2 sections of 3 pins or 2 by 3 pins, and single row header for your motor output right here. So 2 sections of 4 pins. And as I mentioned a moment ago, I was going to use these screw terminals here for my power connection, but I just grabbed a part from the library that I thought was right, and of course it turned out to be wrong, and I didn't double check it. Stupid me. Always double check your designs. Well, I didn't, so this doesn't work. You have to solder your wire straight into this, or find a connector that fits, or I will redesign this board. Actually, I will post a second version that will fit this connector, so that should work for you if you want to use a screw terminal. If you don't, then you can use this original version, won't matter. And another thing that you need is this Panasonic size D capacitor. You need 2 of these. They have to be 100 microfarad or bigger, but it may be difficult to find a bigger capacitor that will fit in this place here, in between the 2 rows of the sockets for the stepper motor drivers. So it has to be Panasonic size D. That's how it's described, and it has to be again 100 microfarad, rated at least 16 volt for 12 volt circuits, or if you're running your printer at 24 volt, then of course it has to be a bigger rating. I don't remember what the next rating up is. I want to say it's probably 35 volt or something like that. So make sure that whatever voltage you run your circuit at, you buy a capacitor that is considerably larger voltage rating than your voltage that you run in the circuit. You don't want to be running a capacitor running rated at 12 volt in a 12 volt circuit. So it has to be more than 12 volt, at least 16 should be good. So that's the part that you need. And then you just put the board together, solder the 2 capacitors first. One goes here, the other one goes here. Then I recommend soldering your female posts here, and then the headers, the 2 row 3 by 2 headers, then these headers, this one, and soldering your power connection. Now here's a catch for this keyed shrouded connector. The pin number 1 by design is marked here. This is your pin number 1, but because on the original MKS Gen PCB the shrouded connector is mounted wrong way around, actually pin number 1 should be here. There's a little triangle marking this, or maybe I can show you this. Here, this is the triangle that marks pin number 1. So really this connector should go this way around. But because on MKS Gen they've mounted this connector wrong way around, you have to do the same on my board. So I did this intentionally, that you rotate it around to match the rotation and wrong orientation on the MKS Gen. And then you can use regular cable and it will work. So remember to turn this around. Pin number 1 needs to go on the opposite side of where it normally would be. And that's pretty much it. You assemble this thing, and then you need to configure your Marlin software to actually support this driver. So that's what we'll get to next.
Before we get into the software configuration of the extension board, let's take a look at the changes that I made to the PCB. So I've changed the connector for the power. This is a larger footprint screw terminal. So now this connector fits. And I've tested this PCB. I printed out the footprints and plugged in some parts, so I know that this fits. So I've moved this connector out a little bit closer to the screw, but there's enough clearance for M3 screw here. And also I've moved out this connector a little bit to accommodate shrouded so that it lays flat against the board. And then the pins go in here. Of course, this will be the positive, and this will be the negative, the ground of the capacitor. You have to pay attention to the polarity, make sure that you get this right. So you stick the pins in here, lay the capacitor flat in this direction, and you should be good to go. So that's if you want to avoid working with S&D parts, which is a little bit trickier. So this is the new version of the board. I will publish it. I'll post a link to it in the description of this video. And either use this version, or if you use wires soldered into these holes, then you can use the original, the older version of the board. Now, as to the software, here are the changes that you need to make. In your configuration.h file, you need to change define extruders 1 to define extruders 4 if you want to use 4 extruders. Of course, you could use 3 extruders with this extension. Just don't populate the 4th driver, and then you would say define extruders 3. Next thing that you need to define is make sure that you define single nozzle, because yes, you have 4 extruders, but you only have 1 nozzle. Next thing is define distinct E-factors. I think that this is a great thing to enable, because then for each extruder you define you can define different steps per unit and max feed rate and all that good stuff. So in the original file, you have your steps per unit X, Y, Z, and extruder. Just one extruder here, 500 steps per unit. In my modified file, because I've defined distinct E-factors, I have my X, Y, Z, and then 4 different numbers, one for each extruder. So as you can see, these numbers do differ a little bit. So you can fine-tune steps per unit for each extruder. You can use different extruders as long as they use the same filament diameter. They can be different types of extruder. If you want to test a new extruder and only build one of them and plug it in, and it vastly differs compared to the other ones, you just change these numbers here and you're good to go. And the same goes for default max feed rate. Again, instead of just one number for the feed rate, you define 4 of these. Default max acceleration, same story. And that's all indicated here in the comments. If you look at the comment, you see that the comment shows extruder 0, optionally extruder 1, optionally extruder 2, optionally extruder 3, or 4. So that's what tells you which of these defines can accept multiple parameters for multiple extruders. Then I've played here with acceleration settings. You may need to work on this to get the right acceleration for your extruders. That's not so relevant. You just have to test your settings and see what works the best. This we can skip. That's also just depending on your machine. Here is the important part, the directions for the extruders. So your original file may come with just 1 or 2 defines here. If you need to add more, do that. And then if you need to invert the directions, also define accordingly. Basically what you can do is just plug in your extruders, try to eject some filament and see if the extruder actually pushes the filament out or pulls it back in. If it goes in the wrong direction, then you just need to change this define. If it says false, change it to true. If it says true, change it to false. So that's how you define or determine what you should have in here. That's and possibly other MKS family boards that have similar connectors on them. Um, so you need to comment out this check, because what it does is it looks at how many hot ends were defined, which hot ends ends up being defined to the same number as number of extruders defined here. So if you define extruders 4, your hot ends will be defined to 4 as well. And this checks if number of defined hot ends is greater than 2. If so, it says that this board only supports up to 2 hot ends, which is true for the regular board without the additional extender that we're adding. So we need to comment this out so that the compilation process doesn't complain about the additional extruders. This part is not relevant. I just added this because I'm playing also with adding the Z probe, so that doesn't matter in terms of adding extra extruders, but you do have to define these settings right here. This is very important. This says that if there's more than 2 extruders, then define these 3 pins, and these are for the 3rd extruder. And then if there's more than 3 extruders, define these 3 more pins, which is for the 4th extruder. So you need to define these, otherwise your software will not know which pins to control to move these additional 2 extruders. But that's pretty much it. Once you compile your Marlin software with these changes, your extruders should be able to move. Just test them, try to extrude out some filament, try to pull in and see where the extruders move in the right directions. Then do your standard measurement of extruding 100 millimeter of filament and measuring that, and that's how you determine your correct number of steps per unit here. Just do some tuning and you should be good to go. But all this is exciting and looks great, except in my tests so far, it seems like Marlin software on 8-bit controllers just cannot keep up with controlling 4 extruders. When I run my printer with 2 extruders, it runs great. All these numbers work fine. I'm getting the right amount of filament extruded. Printer runs smoothly. When I switch to 4 extruder configuration, then the printer movement becomes choppy. I have to actually increase these numbers of steps per unit, which puzzles me why I have to do this, but it seems like maybe some steps are lost. I don't know yet what's happening. I still need to do some testing to figure it out, but it's possible that the software just cannot keep up with handling 4 extruders. So for anyone out there who tries this, if you figure out what's going on and why Marlin firmware slows down to the point that it's really not printing quality parts, if you figure out what's going on, let me know. But that's where I'm at right now. At least you can reproduce my extension board, make the changes to firmware, give it a try yourself if you have the same board that I have, and hopefully with more people looking at this, we'll be able to figure this out. So that's what I have so far. More videos coming. If you like the videos, give me thumbs up. If you like my channel, please subscribe to be notified about new videos. And I'll see you guys later.